welcome to another video. Okay, so today we have this nice question. Yeah, this is a challenge question. Okay, and yes, the night is a nice question. Now this question. Okay, we want to calculate the refractive index because we have here that it is required to determine the refractive index of an opaque dielectric. The polarizing angle is found to be 59.83 degrees when light is refracted from a flat polished surface of the dielectric. So what is the refractive index? Now, I made a video recently about 2 or 3 days ago, where I showed that the angle between a reflected ray and a refracted ray through a glass is 90 degrees. Yes. Now, and that's that question, okay, is more like what we have was in the question. This is just like it looks somehow similar to this question in a way, but not similar, because in this case we want to find out the refractive index of the medium. Now, let me quickly cast our mind back to um, one of my videos where I explain electromagnetic wave. We know that electromagnetic wave is a transverse wave consisting of electric field and magnetic field oscillating perpendicular to each other and to the direction of propagation. One of the simplest type of transverse wave is what we call electromagnetic wave, okay? And electromagnetic wave, like I said, is that wave in which the vibration of the electric field vector is confined to a single, plane perpendicular to the direction of propagation. That's in the case of, just like what we have in the case of plane polarized light. When we have the vibration of the electric field vector, confined to a single plane, when the vibration of the electric field vector is confined to a single plane along the direction of propagation. So this is X, okay, this is Y, then this is what? Z. So we have more like a three-dimensional figure. All right, so in this case, so this will be the direction of propagation. So that's the speed of light. All electromagnetic waves travel at the same speed, which is known as speed of light. Now, so when we talk about plane polarized light, unpolarized light, plane polarized light is a type of polarization, okay? We have plane polarized light. We have what we call the elliptically polarized light when the electric field vector changes with time and the same electric field vector rotates about the direction of propagation. Then in that case, we'll have what we call elliptically polarized light. But in the case of what we call the one we call the circularly polarized light, that is when the electric field vector stays constant, but it will now what? It will now rotate about the direction of propagation. There will be rotation about the direction of propagation, but it will stay constant. All right. But in the case of linearly or plane polarized light, that is when we have the electric field vector to be in a constant orientation. It will be in a constant orientation, and that's in the case of this. So, like I said, it is one of the simplest type of transverse wave is what we call electromagnetic wave or polarization, okay? Because for polarization to occur, it means that the vibration of the electric field vector, okay, will be confined to a single plane along the direction of propagation. And that's when we talk about what? Polarization. That means when we talk about unpolarized light, it will be unpolarized light when the light is in, the light, when we have, unpolarized light is when we have light in which the planes of vibration are symmetrically, distributed, okay, about the propagation of the direction of propagation of the wave. That is, in the case of unpolarized light, the light will not travel along a plane. Okay, the light will not travel along a plane. This is unpolarized light, just like the light in this room. Okay, so it is unpolarized, so so to make the light become polarized, then we have to make use of some optical, like we have to make use of some optical instrument, in order to what? To polarize the light. That is, to have the wave or the light wave to be confined, okay, to a single plane along the direction of propagation. Now, so this is just to educate, for us to understand the concept of, polarization. So, like I said, we have plane polarized light. We have when the electric field vector is in a constant orientation. That's in the case of plane polarized light. And that's the one I just explained, because that's what we are going to be looking at now to be able to solve this problem. Now, again, I need to explain this. Now, there is what we call the Malus law, because now we have many laws, that talks about refractive index of a medium, not only Snell's law. That one is common, okay? But when we talk about Malus law, yeah, that's Malus law. Okay, let me try to remember this, because I used to say this, I know back then, when we talk about Malus, that's in the year 1808. It discovered polarization of light by reflection. Yes, Malus is a French engineer. Yeah, he's a French engineer who discovered the phenomenon of polarization of light by what? By reflection in the year 1808. All right. So now, away from that, how did he how did he perform the experiment? He noticed that when natural light, okay, when natural light is incident on a smooth surface, when natural light is incident on a smooth surface, okay, when natural light is incident on a smooth surface at a polarizing angle, the reflected beam will be plane polarized. Yes, that's it. Okay, so we have, this is the polarizing angle. Okay, we have the polarizing angle. So if you have seen the previous video I made, okay, you would understand what I am talking about. In this case, so we have, this is the refracted angle of refraction, or the transmitted angle. Now, so which means the reflected beam, okay, this light beam will be plane polarized. That is, it will be completely polarized, because when the natural light, fall on the smooth surface at a polarizing angle. Now, let's say this is Q, then this is P, and then this is what? This is R, and this is S. Okay, so the light will be reflected along QR, okay, and it will be what? It will be completely plane polarized light. It will be a completely plane polarized light. Then the refracted beam will be what? Will be partially polarized. Yes, it will be partially polarized, but the reflected beam will be what? Completely plane polarized. Like I said, plane polarization is the one we talks about when we have the electric field vector, okay, in a constant orientation. That is when we talk about plane polarized light. But to be able to solve this question, like I said, it's just for us to understand, the concept. Very important. So now there's what we call the Brewster's law. Now the Brewster's law. Okay, let me say a few things about Brewster's law. It performed a series of experiments on polarization by reflection of light. That's polarization by reflection of light, okay, or polarization of light by reflection. Yeah, polarization of light by reflection at a number of surfaces. Now, he now deduced that the the that is the polarizing angle depends on the refractive index of the medium. Yes, and that's why now he was able to prove that the tangent of angle, okay, at which polarization is obtained by reflection is numerically equal to the index of refraction of the medium. Okay, so just like what I explained here, the angle between reflected ray and refracted ray is always 90 degrees. There's no doubt about that. Okay, it's always 90 degrees. When it comes to when we have when we talk about the Malus law, the Malus law, E.L.Malus, I said it discovered that discovered the phenomenon of polarization of light by reflection, where you notice that when natural light is incident on a smooth surface, okay, when it is incident on a smooth surface, this is the incident light. Okay, we have the incident ray, okay, then we have the reflected ray, and this is the refracted ray. Okay, this is the refracted ray. So now the reflected ray will be completely polarized. It will be completely polarized. That is, it will be confined to a single plane perpendicular to the direction of propagation. So the Brewster's law, like I said, states that now, like I said, Brewster's law, okay, I made mention of the Malus, E.L.Malus, okay. We have the E.L.Malus. You can find out is a French engineer, okay, who discovered in the year 1808, okay, the phenomenon of polarization of light by reflection. All right, so like I said, we have the Brewster's law. We have the Brewster's law. Now, when we talk about the Brewster's law states that, okay, the tangent, this is very important, the tangent of angle, okay, at which, at which polarization, at which polarization is obtained, by reflection, okay, is numerically equal to what? The index of refraction, okay, to the index of refraction of the material medium, or we can say of the medium. So according to this law, so the tangent of the polarizing angle, this is the polarizing angle, will be equals to the refractive index. So this is the polarizing angle. Remember, this angle is known as the polarizing angle. We have the polarizing angle, okay, because like I said, when natural light is incident on the smooth surface, the reflected beam will be completely polarized. So we want to calculate the refractive index. So to be able to calculate the refractive index, okay, so very simple, like I said. Now, so we just have to do now refractive index equals to the tangent of the polarizing angle. So we are given the polarizing angle. The polarizing angle is found to be 59.83 degrees when light is refracted from a flat polished surface. That diagram, okay, from a flat polished surface, that smooth surface, okay. After the light is reflected, okay, it is also what? Refracted. So the refracted, this is the incident ray, which makes which makes an angle known as polarizing angle with the normal. Okay. Then we also have this to be what? Polarizing angle. Okay. Now, remember I explained this in that video that because we have angle of incidence to be equals to angle of reflection. So that's what plays out here. So the polarizing angle, okay, of incidence will be equal to the polarizing angle of reflection. So, like I said, this will now be what? The refracted angle of refraction. That's the bending. That's how the bending light makes an angle with the normal ray. So this will be partially, like I said, this will be partially polarized, and this will be what? This will be completely plane polarized. Yeah, yeah. It will be completely plane polarized. Yeah. All right. So we have like I said, we have the polarizing angle. We have the polarizing angle. so that we can say that this is tangent of this angle 59.83. Okay, remember polarizing angle is what we have here as we have the polarizing angle, okay, to be 59.83. 59.83. That's the polarizing angle. So let's get the tangent of 59.83. Tangent of 59.83. Yeah. So that will be 1.72. So the refractive index of the material medium will be 1.72. And that is what we are asked to, calculate. That is the refractive index of the material medium. The noblest pleasure is the joy of understanding.